Good day, everyone, and welcome to where we are putting together solutions for students who are struggling in the area of additional mathematics, which is under the banner of the Caribbean Secondary Examination Council, or CSEC. And we'll be looking today in this video at May 2025, Paper 2. Don't forget to like the video and add any comments down below so we can help by creating other content for the areas in which you are having specific problems. If we look at the description down below, you will be able to see the playlists that we have identified that you should follow in that order in order to cover this entire course in the most efficient and successful manner for yourself. Don't forget, we have similar channels for CSEC Mathematics, which started since 2009, including notes and past papers solutions. And we also have for primary mathematics as well. Let's now look at the breakdown of the entire additional mathematics syllabus. If we look, you will see that there are 4 sections, and let's recognize that paper 1, which is considered to be multiple choice, there are 45 items, and paper 2, which is considered to be the long paper, is worth 100 marks. There's also paper 3, which is the SBA, the school-based assessment. So let's look at the first section, algebra, sequences, and series. And if we look at the breakdown of this first section, the first topic is algebra, in which there are 2 questions coming in paper 1. Quadratics, there are 3 questions in paper 1, or 3 multiple choice questions. Inequalities, there are 2 questions there as well. Functions, there are 4 questions being assessed in the multiple choice. 5 on surds, indices, and logarithms. And the rest on sequences and series, which in total gives us 20 of the 45 questions in paper 1, is based on section 1. And the first 2 questions in paper 2 will also be testing section 1, which each is worth 15 marks, giving us a total of 30 marks. Moving on to section 2, coordinate geometry, vectors, and trigonometry. Coordinate geometry, there are 3 questions that will be assessed in this area in paper 1, 3 questions on vectors, and the next 8, which makes up 14 questions of paper 1 that assesses section 2. In paper 2, the long paper, there will be only 1 question, number 3, that assesses section 2, and that is worth 20 marks. We now move on to introductory calculus, and that is broken up into 3 areas: differentiation, integration. Differentiation is worth 5 marks, or 5 multiple choice questions are assessed in this area. 6 in integration, and kinematics. There are no questions being assessed on kinematics in this paper 1. So 5 and 6 gives us 11. And if we total that, 20 and 14 is 34, and 11 is 45. That means that paper 1, the entire of it is assessed in these areas that we have identified, from algebra up to integration. And in paper 2, there are 2 questions each being 15 marks, number 4 and 5, giving us a total of 30 marks. And finally, we come to probability and statistics. And 20 and 14 and 11 is 45, which means there are no questions in paper 1 on probability and statistics. It is broken up into two topics, of course, probability and statistics. And it comes as the last question in paper 2, number 6, with 20 marks, which gives us a total of 100 marks. In terms of overall percentage, paper 1, which is 45 multiple choice, will be converted to 30% of your overall mark. Paper 2, which is 100 marks, will be converted to 50% of your overall grade. So that's 30 and 50 is 80%. And the last 20% will be on your SPA. Let's now look at what is provided in the examination, which is a list of formulae. The first formulae will be on the topic of arithmetic series, meaning APs. We have t to the n, which means it gives us a formula to identify the nth term, and also a formula to give the sum of the n terms, s to the n. The geometric series gives us t to the n. The nth term we can identify in the geometric series, the sum of the first n terms, and if the geometric series will be able to find the sum to infinity when the modulus of r is less than 1, r being the common ratio. There are two formulas on circles, which basically gives you the same circle. It's just the format in which it's identified. The second one with r squared means r is the radius of the circle. We can easily identify the center of the circle from f and g. And the expanded form of that will be the first one, x squared plus y squared plus 2fx plus 2gy plus c. And now we have formulas for the topic of vectors, where we can find the unit vector. We can also find the dot product. A dot B is equal to mod A mod B cos theta, or this form, making cos theta the subject of the formula. And we can find the modulus, or the length of the vector V, using basically Pythagoras' theorem. There are topics in trigonometry. There are three formulas, which are the compound formulas for the trigonometric ratios sine theta. So sine A plus B or A minus B, cos A plus or minus B, and tan as well, A plus B or A minus B. Formulas are provided for kinematics. The first three, V is equal to U plus AT, V squared is equal to U squared plus 2AS, and S is equal to UT plus a half AT squared, are identified and exactly the same as the ones that are done in physics. For the equations of motion, we also are able to show a relationship between V and the distance by saying V is equal to dx dt, also known as x dot, and A is equal to d2 dx dt squared, which is equal to dv dt, which is equal to x double dot. And after kinematics, there is calculus, where the first formula shows how we can differentiate a linear equation to the power n, where we can differentiate multiple angles of sine theta, meaning d dx of sine ax, as well as differentiating cos. And of course, the relationship in terms of integration, where we can integrate the velocity with respect to t and find the distance s, and integrate the acceleration with respect to t and find the velocity. We now go to statistics, where in the first case, we can tell what x bar is, the mean, by summing the terms from 1 to n, meaning we adding up all the terms and divide by n. And for s squared, which gives us the variance, we can find it in terms of a sample by seeing the difference between each term and the x bar, squaring it and getting that sum and dividing by n minus 1. And that will be assessed in this paper as well. And finally, the formula given for probability. Let's now actually move into the paper. We'll be looking at May 2025, number 1, which says, solve the equation 3 to the power 2x plus 1 is equal to 21, giving your answer in exact form. And if we consider x to be 0, then 2 zeros are 0 plus 1 is 1. 3 to the power 1 is 3, which is less than 21. So x is not 0. If we try x is equal to 1, 2 ones are 2 and 1, 3. So 3 to the power 3, or 3 cubed is 27. That means x lies somewhere between 0, which give an answer of 1, and 1. So let's go see if we can work it out. 3 to the power 2x plus 1 is equal to 21. And if we would like to find that power, or the index, then we can apply logarithms to both sides. So log 3 to the index 2x plus 1 is equal to log 21. That means, if you're not seeing a base there, it's understood, is to the base 10. And if we apply log 10 in C, then it means 2x plus 1 is equal to log 21 to base 3. And now we can separate that 21, because 21 is just 3 times 7. So you have 2x plus 1 is equal to log 3 times 7 to base 3. And of course, from the rules of products that you've done in logarithms with your teacher, log B times C is equal to log B plus log C all to the same base. So that means we can split up, we can let B be the value 3 and C be the value 7. So when we rewrite it, we have 2x plus 1 to log 3 to base 3 plus log 7 to base 3. And if we have any number and we apply logs to it with same base, log A to base A, it will be equal to 1. As such, we can simplify log 3 to base 3 and rewrite it as 2x plus 1 is equal to 1 plus log 7 to base 3. And now we have 1 on both sides, so we can minus 1 from both sides. We'll be left with 2x is equal to log 7 to base 3. As such, x is equal to half log 7 to base 3. So we're giving our answer in the exact form. Let's now move on to part B. Determine the values of x and y which satisfy the equations y plus 3x equal to 2 and y plus 4 is equal to x by brackets 5 minus 2x. Now, what we're seeing here is two different equations, and if we're trying to determine the values which satisfy them, it means that we would like to know the term of x and the values of y which satisfy both equations. Or we can say it differently, we're solving the simultaneous equations. So the one on the left-hand side, we'll consider that equation 1. We can see it's linear because the highest power of x is 1. And the one on the right-hand side, equation 2, that will give us a quadratic. So I'll bring up a sketch of what equation 2 looks like. You will not have that provided in the examination, but this is to give us a concrete idea of what's going on. And now we can take equation 1 and manipulate it. So we have y plus 3x equal to 2. Notice I have y in a different color, just for you to identify it easily. So y is equal to 2 minus 3x. And let's consider that to be equation 3. So now let's rewrite the quadratic equation. And so let's identify the line. And that blue line, y is equal to 2 minus 3x. So you can see it is intersecting equation 2 at 2 different points. So we'd like to find the values of those 2 points. So let's write equation 2. Y plus 4 is equal to x by 5 minus 2x. And we have y, I have it in a different color just for ease for you to be able to identify it. And we're going to substitute for y, because in equation 3, we know y is equal to 2 minus 3x. As such, 2 minus 3x plus 4 is equal to x by 5 minus 2x. And now we can expand. So on the right-hand side, we'll have 5 times x is 5x minus 2x squared. And you can see it's a quadratic equation. And to solve a quadratic, we want to make one side is equal to 0. So let's move the two terms on the right side and carry them across, meaning that we're getting the inverse of the terms, we're putting them on the left. So minus 2x squared, when we rewrite it, will become 2x squared. And we have minus 3x already on the left side, and we have plus 5x becoming minus 5x, plus 2 plus 4 is equal to 0. And of course, we can simplify that. 2x squared minus 3x minus 5x is minus 8x, plus 2 plus 4 is equal to plus 6. All of that left-hand side is equal to 0. And for simplicity, we can divide every term in that equation by the number 2. So 2 into 2x squared is x squared. 2 into minus 8x is minus 4x. 2 into plus 6 is plus 3. And 2 into 0 is 0. Now we have a quadratic equation, and we can solve using the quadratic formula, or this can factorize. When we factorize this, we're going to get x minus 3 as the first linear factor by x minus 1 is equal to 0. So either the first factor, x minus 3, will be equal to 0, which implies that x is equal to 3. And let's go onto the graph and input that arrow. So we know somewhere along that line where x equal to 3, the two equations, equation 1, the blue line or the linear equation, and equation 2, the quadratic, will intersect. And it's proven on the graph. So there's a second factor because it's quadratic, so there'll be two factors. So either x minus 3, the first factor, is equal to 0, or the second factor is equal to 0. In either case, if one of them is 0, then the multiplication will give us 0. So if x minus 1 is equal to 0, this implies that x is equal to 1. Let's put that on the graph as well. So you can see, look, the points of intersection line up with what we're solving so far. Now we found the x values. In order to get the coordinates to satisfy the equation, we now need the y values. So let's now go and take when x is equal to 1. We can substitute in either equation 1, equation 2, or equation 3. All of them will give us the y value. The easiest one to work with may be the third equation. So let's rewrite that. And now let's substitute. Y is equal to 2 minus 3 times 1. 3 ones are 3, 2 minus 3. So y is equal to minus 1. So at the point when x is equal to 1, y is equal to minus 1. Let's put that on the graph so we can see that point of intersection. Let's now go do it for the second point of intersection when x is equal to 3. We're going to use this third equation again because it's the easiest to just substitute into. Y is equal to 2 minus 3x. So y is equal to 2 minus 3 threes. 3 threes are 9. 2 minus 9 is minus 7. So when x is equal to 3, let's put it there. Y is equal to minus 7. And if we substitute into equation 1 or equation 2, they will both work out as well. Let's now move on to number 1, part C, where in this question, part 1 is asking us to determine the solution set for the inequality 3x plus 2 divided by x minus 1 is less than or equal to 0, giving your answer in set builder notation. Just recall, we have to manipulate this somewhat in order to be able to get the key points to find out which range this lies in, this inequality. So if we multiply throughout by whatever the denominator is, squared, we multiply it on the left-hand side and on the right-hand side. We will have x minus 1 can cancel off with one of the x minus 1s on the left side because it's squared. So it's x minus 1 times x minus 1. So the denominator factor will cancel with one of the factors in the numerator. And on the right-hand side, we have 0 times x minus 1 squared. So we multiply by both sides with the same thing, so it doesn't actually change the inequality. So it looks like this. 3x plus 2 by x minus 1 on the left-hand side is less than or equal to 0, because 0 times anything is 0. Now, we're doing this form in order to find the two key points for this inequality. If we consider it to be a quadratic equation meaning it's equal alone, not less than or equal to, then we could consider, just like the last question, as two factors. So either 3x plus 2 is equal to 0, so 3x is equal to minus 2, and as such, x is equal to minus 2 over 3, or minus 2/3. Or, for the second factor, x minus 1 is equal to 0, which means x is equal to 1. So if we bring up a number line, so we can visualize where this is. So now let's substitute when x is equal to minus 2/3 back into the original inequality, 3x plus 2 divided by x minus 1. Then 3 times minus 2/3 will be minus 2. Minus 2 plus 2 is 0, so the numerator works out to be 0. And minus 2/3 minus 1 is minus 5/3. That's the denominator. 0 over any number is equal to 0. So it holds. Therefore, look, we've put it up onto the number line. At the point where it is minus 2/3, we have to draw a solid circle, which means that for this inequality to work, when x is minus 2/3, it will give us, it will satisfy that inequality. The other point, when x is equal to 1, let's now substitute back into the original equation. 3 times 1 is 3. 3 plus 2 is 5, so you're going to get 5 on top. And 1 minus 1 is 0. 5 divided by 0. We cannot divide by a 0. So the answer is undefined, which means that at the point when x is equal to 1, we cannot consider that. That will not give us a solution. So at the point x equal to 1, when we identify that, we're going to bring up a circle whose center is empty or open, which means that at the point when x equal to 1, it does not satisfy that fraction. Now, where does the range lie? Does it lie to the left of minus 2/3 or to the right? Does it lie to the right of 1 or to the left? So let's go substitute. Let's pick a value. Let's say at this point here, minus 1. So it's to the left of it. And we're going to look at, we could either look at the fractions or we could look at the product. So let's look at the product here at 3x plus 2. When x is equal to minus 1, 3 times minus 1 is minus 3. Minus 3 plus 2 is minus 1. So that gives us a negative solution. And when x is minus 1, minus 1, minus 1 is minus 2. So that also gives us, for the second factor, a negative solution as well. So a negative, whatever the value is, multiplied by a negative is a positive number. And a positive number, any positive number, is not less than or equal to 0. So if we look at where minus 2/3 is, where the red arrow is, anything to the left of that will give us a positive result. And that positive result will not hold for this inequality. So it does not work there. All right, let's change it. And let's look at the right of the empty set of 1. So let's pick any value you want. We could use 10 if you wish. So 3 10s are 30. 30 plus 2 is 32. That's plus 32. And 10 minus 1 is 9 plus 9. So a positive times a positive number, any positive numbers there will give us a positive result. A positive result will not hold for this because less than or equal to 0 means it's either negative or equal to 0. So it doesn't work to the right of x equal to 1 either. So it didn't work to the left of minus 2/3. It didn't work to the right of 1. So let's now go look in the middle. And at this point, let's pick x equal to 0. So 3 times 0 is 0. 0 plus 2 is plus 2. So that's a positive result. And when x is 0, we're looking at the next factor. 0 minus 1 is negative. A positive multiplied by a negative is a negative. As such, that is less than or equal to 0. So what we've realized from this is that the range in which this works, it's starting from minus 2/3 on the left and going towards 1 on the right. It includes the minus 2/3. At that point, it works out to be 0 and the inequality says less than or equal to 0. But it does not include the 1 because at the point when x is 1, it is undefined. We cannot get a result. So let's write that. So when x is greater than or equal to minus 2/3, going to the right of it. And when x is less than 1, our green line shows the solution. So we could write it as minus 2/3 is less than or equal to x, which is less than 1. And this is the solution for the rational expression, 3x plus 2 over x minus 1. Now part 2 says, state how the solution of 3x plus 2 times x minus 1 is less than or equal to 0 would differ from the quotient or the fraction. So we have already found for the algebraic fraction, it is inclusive of minus 2/3, but does not include 1. Because at that point, 1 is undefined. So let's find for the other version where there's a multiplication for 3x plus 2 where by x minus 1, we have already done the working. When x is minus 2/3, if we look on the either or on the left-hand side, at the point when x is minus 2/3, that is one result. At that point, this equation works out to be 0. When we substitute it, we can see 3 times minus 2/3 is minus 2. Minus 2 plus 2 is 0. 0 times anything is 0. So it works here at minus 2/3. What about when x is equal to 1 on the right-hand side? If we substitute into this product, 1 minus 1 is 0. 0 times 3x plus 2 is 0. So 0 is equal to 0. So it works when x is equal to 1. It's inclusive. And using the range as is, we've just realized that its green line still holds. So the difference in the results are just now, when we're looking at the algebraic fractions, we saw that it included minus 2/3, but did not include 1. X was less than 1. When it's a product, right, what varies is our answer will be minus 2/3 is included, minus 2/3 is less than or equal to x, and x is less than or equal to 1. Because at 1, it works. It is defined. Let's now move on to number 2, where we're looking at the relationship between two variables x and y is 10 to the power 2x times 10 to the power y equal to 3. Express the relationship in the form y is equal to log b plus ax, where a and b are members of the real numbers. So let's bring up the equation. And if we have indices and we would like to get the powers, then we can combine them, because if we're having the two terms with the same base, 10 to the power 2x times 10 to the power y, then we can be rewritten using our indices laws as 10 to the power 2x plus y. And now we can apply logs to both of them, log 10 to both sides. What will happen is, if you recall that any log b to base a with a power k, the k can become the coefficient of it. So if we see log 10 to the power 2x plus y to base 10, then k is considered to be 2x plus y, so we can bring the k in front. So we get 2x plus y by log 10 to base 10 is equal to log 3 to base 10. And any number where we apply log to the same base means log a to base a will give us 1. We did that a little bit earlier in number 1. So 2x plus y by 1 is equal to log 3. And why can we write log 3? Because log 3 to base 10, the 10 is understood, so we can just write log 3 alone. As such, we do the multiplication, we get 2x plus y is equal to log 3. So let's go back to what is being required above. X is equal to the relationship in the form y, express the relationship in the form y is equal to log b plus ax. So if we manipulate this last line we have, then we can write y is equal to log 3 minus 2x. And it looks very similar to what is above. Y is equal to log b plus ax, where b is 3 and a is minus 2. Let's now go on to part 2. Hence, state the value of the y-intercept of a graph of y versus x. So if we consider a straight line graph, y is equal to mx plus c, that's normally the standard in many of the textbooks, m being the gradient, c being the y-intercept. Well, in this case here, look where x is. So it's just a rearranging of that mx plus c to be in c plus mx, and it's still a straight line. So for the straight line graph, the gradient m is minus 2. But what is the question asking us for? It's asking for the y-intercept. The y-intercept is c. So y is equal to, the y-intercept is log 3. Let's now move on to part B. Determine whether or not the series 2 plus 6 plus 18, and you can see the series going on, is arithmetic or geometric. And we have to justify your response. So if we consider the first term and the second term, if there's a relationship between them, and if the same relationship between the second term and the third term, and the third term and the fourth term, right? Then let's try dividing so that we see T2 over T1, which is 6 divided by 2, which works out to be 3. As such, if this happens to be the relationship, then we can see that to get the second term, we take the first term and multiply by 3. 3 times T1 is equal to T2. 3 2s are 6. What happens between the third term and the second term? Well, that is 18 divided by 6, which is also 3. So just how we had the first term and we multiplied by 3, we got the second term. We're taking the second term and multiplying by 3, we get the third term. And what about the fourth term and the third term? T4 divided by T3 is 54 divided by 18, which is also 3. So we're seeing a pattern here, which is one definition of math, that math is patterns and relationships. What about the next term? The fifth term divided by the fourth term, 162 divided by 54, that's also 3. As such, we have what we call a common ratio, normally recognized as R, to be equal to 3. Meaning there's a common ratio between one term and the term which precedes it. So we would like to look at the question again, determine whether or not the series is arithmetic or geometric. Since we have a common ratio, thus it's a geometric progression. Let's now move on to number 2C. In a geometric progression, the third term is 25, and the sum of the first and second terms is 500. Find the common ratio where R is greater than 0. So it's a geometric progression, and we know the third term. So there's a formulae that were given for geometric series. The nth term is ar to the power n minus 1. And if the third term is equal to 25, then n is equal to 3. So t to the power 3 is equal to a, we don't know that, we don't know the first term, times r, the common ratio, which we do not know, times n minus 1, to the power n minus 1, 3 minus 1. And that is 25, so we could substitute 25. ar squared is equal to 25. Now, what else do we know? We know the sum of the first and second terms is 500. Right, so we can rewrite that a little bit, sorry. So we can carry the r across, so ar is equal to 25 divided by r, equal that equation 1. Now let's look at the sum of the first two terms. The s to the n, there's a formula for that, as you can see, given in the formula sheet. I'm just showing you what is provided. And for the first two terms, so n is 2. So s to the 2 is equal to a, the first term, times r to the power 2 minus 1 all over r minus 1. So we know s to the power 2 is 500. So we can rewrite that 500 is equal to a times 2 minus 1 is 1. So r to the power 1, or ar all over r minus 1. So we've taken the information above and come up with two separate equations. ar is equal to 25 over r, and 500 is equal to ar all over r minus 1. So if we recognize that, we can now take equation 1 and equation 2 and substitute one into the other. So ar from equation 1 is 25 over r. So we can rewrite equation 2 and replace ar by 25 in the numerator and r in the denominator. So 500 is equal to 25 divided by r minus 1. And of course, now we're going to manipulate that and be able to solve, because there's only one unknown in this equation. Prior, in equation 1, there were two unknowns, a and r, and equation 2, there were two unknowns, a and r. So we're taking the two equations and these simultaneous equations, I'm going to solve for the unknowns. And specifically what we want to solve for is find the common ratio r from above. So we now have eliminated a, and we are now able to manipulate it. So we could carry the denominator across, so we get to 500. r times r minus 1 is equal to 25. Of course, we can expand. 500r times r is 500r squared. 500r minus 1 times minus 1 is minus 500r is equal to 25. And if we would like to solve a quadratic equation, as we've said before, it's easiest when we're able to make one side of the equation equal to 0. So we have 500r squared minus 500r minus 25 is equal to 0. And we could do a couple things. We could divide by 25 throughout if we wanted to make it simpler. Right? And we can this question is a little difficult to solve if we're trying to factorize it. Therefore, let's use the quadratic formula. And because we're doing that, it's a calculator, it doesn't matter if we divide or not. The calculator will handle the operations part of it. So the first term, a, which is the coefficient of r squared, is 500. I have that in red. The coefficient of r is minus 500. We have that in green. And the term with x to the power 0 is minus 25. So let's write the quadratic formula, which is not x in this case, is r we're finding for, minus b plus or minus the square root of the determinant all over 2a. So let's substitute. For b, we have minus 500, so it's minus 500 plus or minus the square root of minus 500 squared, minus 4 times a, which is 500, times c, which is minus 25, all over 2 times 500. Of course, if we divided by 25 earlier, we'd be using smaller numbers, but it'll still be given the same answer. And because you have a calculators, it'll be able to handle that easily. R is equal to minus 500, which is 500, plus this or minus the square root of minus 500 squared, which is 250,000, minus 4 times minus 5 is 100 times 500 is 50,000, all over 1,000. So R is equal to 500 plus or minus the square root of 300,000 over 1,000. So when we work that out, we can either add and get one solution for R, or subtract to get another solution for R. So if we subtract 500 minus the square root of 300,000 all over 1,000, that approximates to minus 0.05. Let me just show you that again. 500 minus the square root of 300,000 is approximately minus 50. And when we divide by 1,000, it's going to give us minus 0.05, approximately. Now, if we go back to the question about the which we have in blue, that find the common ratio R. Well, we have, but they gave a particular solution where R must be greater than 0. R is minus 0.05, so it does not work. We will not be taking that solution when we subtract it. So let's add 500 plus the square root of 300,000 all over 1,000, which works out to be 1.05 approximately. As such, that will be the solution we'll be taking, the positive solution, which is greater than 0. So we've solved the simultaneous equations in number 2C. Let's now move on to D. A kitchen garden has an area. Right? Remember, if we consider it to be A, which is 10 minus 3 root 5. So 3 root 5 is a third. The length of the garden is 5 minus 2 root 5. Determine the value of A, which is the width of the garden in meters. Okay. Is in the form A plus root 5, where A is a real number. If we consider this to be a rectangular garden, because you're looking at length and width, then area is length times breadth or length times width. As such, we can divide, because what are we trying to find here? We're trying to find the width of it, or the breadth. So the breadth is area divided by length, which came from the formula area is length times breadth. And we have area. Look at it, it's 10 minus 3 root 5. And now we know the length as well, 5 minus 2 root 5. So if we divide those, we're going to get the breadth. Now we have two terms in the numerator. It works out to be a third. In the denominator, it's also a third. So how do we handle questions in which there's a division of 2 thirds? But the easiest way would be to rationalize the denominator. What does that mean? It means that we want to make the denominator a whole number. So we can multiply throughout by the same denominator, except we're changing the sign of it. So if we multiply throughout by 5 plus 2 root 5, meaning if we multiply the numerator and denominator by 5 plus 2 root 5, so we're, in order to know what we want to multiply by, this little trick, we're taking the denominator and changing the sign. Then B, which is what we're trying to find, the breadth, is 10 minus 3 root 5 all over 5 minus 2 root 5 multiplied by the same term in the numerator and denominator, 5 plus 2 root 5 over 5 plus 2 root 5, which actually reduces to 1. So if we have this fraction here, and we're multiplying by 1, then it's not changing the value on the right-hand side. Now, what happens when we look at this and we multiply the denominators, 5 minus 2 root 5, multiply by 5 plus 2 root 5. Some of you know it as the difference of squares. I just want to show you it visually so you can remember. 5 plus 2 root 5, many of your teachers would have done it this way. Or use FOIL, multiply by 5 minus 2 root 5. So the first term by the first term, 5 5s are 25. First term by the second term, 5 times 2 root 5 is 10 root 5. And then 5 times minus 2 root 5 is minus 10 root 5. And 2 2s are 4. Root 5 times root 5 is 5. And what do we realize? Look at it carefully, those 4 terms. The second term, 10 root 5, are bringing up in yellow. And the third term, one is positive and negative of each other. They're the additive inverse. So when we add those up, 10 root 5 minus 10 root 5 works out to be 0. So we left with 25 minus 4 5s are 20. So we can rewrite this. B is equal to 10 minus 3 root 5 multiplied by 5 plus 2 root 5 all over 25 minus 20. 10 5s are 50. Let's use FOIL on top. 10 5s are 50 to multiply. Or you can use any method you wish. 10 times 2 is 20 root 5 minus 3 5s are 15 root 5 minus 3 times 2 is 6. Root 5 times root 5 is 5. All over 25 minus 20 is 5. So we have 50 minus 6 5s are 30. That gives us 20. Plus 20 root 5 minus 15 root 5 is 5 root 5. So we have 20 plus 5 root 5 all over 5. And of course, when we have it like this, we can separate it to 20 over 5. 5 and 20 is 4. And 5 root 5 over 5 is just root 5. So the answer is 4 plus root 5. Let's move on to the second section of the paper, which deals with coordinate geometry, vectors, and trigonometry. Number 3A, part 1. Using the grid, draw the graphs of sine 2x and cos 2x within the range where the angle x lies between 0 and pi. Remember, pi is in radians. If you want to convert it to degrees, it's between 0 and 180 degrees. So let's plot the points. When x is 0, 2 times 0 is 0. So sine of 2 times 0 is 0. When x is pi on 4, 2 times pi on 4 is pi on 2. Sine of pi on 2 is 1. When x is pi on 2, or 90 degrees, and we multiply by 2, that will give us 180 degrees, or pi. Sine of pi is 0. When x is 3 pi on 4, we multiply by 2, we get 3 pi on 2, which is 270 degrees. And pi is only positive in the first and second quadrants. As such, when pi is at 3 pi on 2, it means that it's negative. So we have negative 1. We can use our calculators, get these values. And finally, when x is pi, 2 pi is equal to 360, which is the same as 0 degrees. So sine of 0 is 0. So let's connect the points so we can see the sine 2x curve. Let's do the same for cos 2x. When x is 0, 2 zeros are 0. So cos of 0 is 1. And when x is pi on 4, we multiply by 2. We get pi on 2, or 90 degrees. Cos of 90 is 0. When x is pi on 2, 2 times pi on 2 is pi, or 180. Cos of 180 is negative 1. When x is 3 pi on 4, and we multiply by 2, we get 3 pi on 2. Cos of 3 pi on 2 is 0. And finally, when x is pi, cos of 2 pi is the same as cos of 0, which is 1. So we can connect it. And we have sine 2x and cos 2x. So we drew the graphs. Part 2. Hence, or otherwise, solve the equation sine 2x equal to cos 2x. So if we want to know what do we mean by sine 2x equal to cos 2x, it means where the blue line meets the, what color is that, yellow? Yellow line or orange line. So they intersect at one point here between 0 and pi on 4. Right? May or may not be exactly in the middle. And it also intersects at the second point. So the two graphs Sine 2x equal to cos 2x. They meet each other at 2 points within this range of 0 and pi. So we can also do it the theoretical way, which says that sine 2x equal to cos 2x. If we divide both sides by cos 2x, the right-hand side will be cos 2x over cos 2x, which is 1. And the left-hand side will be sine 2x over cos 2x. And what is sine over cos? That gives us tan 2x. So tan 2x is equal to 1. If we want 2x alone, we can move it across by finding the inverse. So arctan or tan inverse of 1 is 2x. And if we think of that as 45 degrees, or it is pi on 4. That's what 2x is. Now remember that if we have 2 on 4, pi on 4, where else is tan positive? It will also be in the third quadrant, because tan is only positive in the first and third quadrants. So if we have pi on 4, we will also have it at pi plus pi on 4, which is 5 pi on 4, and 2 pi plus pi on 4, which is 9 pi on 4. And it continues. So 2x is equal to these different values. As such, x is equal to pi on 8, 5 pi on 8, 9 pi on 8, and we have a range. We're starting from 0 and ending at pi. So 9 pi on 8, even though it's correct, is outside the range. So for this question within the range as given, x, or the angle at which sine 2x equal to cos 2x is at pi on 8 and 5 pi on 8. We could have also seen from the graph quickly that is exactly between 0 and pi on 4, which is pi on 8. And exactly between pi on 2 and 3 pi on 4, which is 5 pi on 8. So it could have also been read out from the graph as well, without having to do this working. Let's move on now. We're still in that section 2 topic, which has only one question in paper 2 in number 3. So part B, using an appropriate double angle formula, derive the identity of sine 2x. So let's recall this was a formula we spoke about earlier as part of the list of formula given in this exam. So they gave us sine A plus or minus B is equal to sine A cos B plus or minus cos A sine B. So if we consider the positive aspect only, sine A plus B is equal to sine A cos B plus cos A sine B. And let A and B both be equal to x. Then we'll have sine x. We're replacing A by x and replacing B by x. So we're going to get sine x plus x is equal to sine x cos x plus cos x sine x. So x plus x is 2x, and sine x cos x is the same as cos x sine x. So sine 2x is sine x cos x plus sine x cos x by the law of commutativity. And sine x cos x added to sine x cos x is equal to 2 sine x cos x. So sine 2x is equal to 2 sine x cos x. So we've used the appropriate double angle formula in order to find the identity for sine 2x. That's part 1. Let's now go on to part 2. Hence, prove the identity 1 plus sine 2x over sine x plus cos x is equal to sine x plus cos x. So if we want to use sine 2x from part 1, then we have to manipulate the left-hand side, because that's where the sine 2x is. So in order to prove the identity, let's rewrite the left-hand side. 1 plus sine 2x is equal to sine x plus cos x. And we can substitute what we just had there. 1 plus what is sine x 2x? 2 sine x cos x. over the same denominator. And if we recall, 1 is the same as sine squared to x plus cos squared x plus 2 sin x cos x. So we're manipulating the numerator, right? And if we look at it like that, then let's rearrange it slightly. Sin x squared plus 2 sin x cos x plus cos squared x. Hopefully we can see that looks like a squared plus 2ab plus b squared, which is the same as a plus b by a plus b. So sin x plus cos x by sin x plus cos x. We're factorizing the top, which means that we can reduce sin x plus cos x by sin x plus cos x, and that leaves us with sin x plus cos x, which is what? Our right-hand side. And since we have proven the trigonometric identity, we can either just draw this little square, or we can write QED, one of the or the other. QED is Latin for quod erat demonstrum, which means that we have proven it. Let's now move on. We're still in this paper 3, which means this number 3, which is section 2 of the paper. So part 1, we've now reached the vectors question. The position vectors of the 2 points A and B, whose coordinates are 2, 3, and minus 3, 2, respectively, are relative to an origin O. So what I ask my students to do, it seems to help them a lot, is to make a little sketch. They don't even need to put in all those values there. We just want an idea what it looks like. So we have the origin. A is at 2, 3. The x value is 2. The y value is 3. And B is at minus 3, 2. So it's going to the left and up. As such, part 1, express the unit vector AB in terms of xi and u and yj. So AB moves from A to B, that's the black line. Now, how can we move from A to B? We can start at A and go to O. So that's AO, and then from O to B. Now, we don't have AO. We have the opposite direction, O to A. So what's the difference? AO can be replaced by minus OA, which means OA in the opposite direction. And you can substitute the values above. So OA is 2i plus 3j, the only negative of that, plus OB is minus 3i plus 2j. I and j are the unit vectors. I is a unit vector in the direction x, and j is a unit direction in the direction y. And now minus 2i, minus 3i, put them together, and minus 3j plus 2j. So minus 2i minus 3i is minus 5i, minus 3j plus 2j is minus 1j. And if we think of A going to B, we are going to the left and then downwards. So if we go to the left, we're going minus 5, and then we're coming down minus 1. So now that we're able to get the AB, we now want to get the length of it, the modulus of it. And if we think of AB, we can see a right angle triangle there. So we can apply Pythagoras' theorem. Change in x squared plus change in y squared is equal to the hypotenuse squared, which is AB squared. So those two straight lines mean modulus of the vector AB, meaning the length of AB. Or in this case, we could call it the hypotenuse squared. So minus 5 squared is 25, minus 1 squared is 1. So 25 and 1 is 26. As such, the modulus or the length of AB squared is equal to 26. So AB is the square root of 26. Now if you go back to the question, we're trying to find the unit vector of AB. What does that mean? The unit vector is the actual vector divided by its length. So that is minus 5i minus 1j all over the square root of 26. And that means that if we apply this we would move a distance of 1 along the direction of AB. Let's move on. That was part 1. To part 2, find the angle AOB. And we can see from the triangle there, the angle between OA and OB in degrees. If we call OE dot OB is equal to mod OAOB cos theta. And how do we find the dot product of OE and OB? Well, using the dot product or scalar product, then it can be written like this. The length of OA, just like Pythagoras' theorem, 2 squared plus 3 squared, opposites O squared plus A squared, equal to 8 squared. So if you want H, we want the square root of that. You've done many of this in class with your teachers. And OB is minus 3 squared plus 2 squared cos theta. The angle between OA and OB, which is what we want to find, is equal to the dot product of 23 dot minus 32. I have them in different colors, so let's remind ourselves. If we have A1, B1 dot A2, B2, in order to get the scalar product, we multiply the A terms, or in this case, the terms blue and red, plus we multiply the B terms, B1 and B2, or the terms that are in green and black. So it'll be 2 times minus 3 plus 3 times 2. Look at the colors so you can see it. Is equal to, what is 2 squared? That's 4 plus 3 squared is 9. 4 and 9 is 13, so the square root of 13. Minus 3 squared is 9, plus 2 squared is 4, 9 and 4 is 13, so that's also the square root of 13. Square root of 13 times square root of 13 times cos theta. So now, if we look at this line here, we can see the equation has only one unknown. So we can manipulate it. 2 times minus 3 is minus 6, plus 3 times 2 is 6. Minus 6 plus 6 is 0. 0 is equal to 13. Root 13 times root 13 is 13 cos theta. So therefore 0 is equal to cos theta. The only way for 13 multiplied by cos theta to be 0 is if cos theta itself is 0. Which means that theta is 90 degrees. Now if theta is 90 degrees, that's very interesting. Let's put a little 90-degree symbol there on our sketch. We have it in red. Let's go to the last part here, part 3. Hence, state the relationship between the vectors OA and OB. Well, we notice that there's a 90 degrees there that we just worked out. As such, we can see that the vectors OA and OB are perpendicular to each other. They are at 90 degrees to each other. Let's now move on to section 3, where that indicates calculus. So in the first part, part A, differentiate the following expression with respect to x. Simplifying your answer, y is equal to sine 4x plus 3, x to the 4th. So if we differentiate, that's what they're asking us to do. So d dx of y, then we're differentiating the right-hand side, is sine 4x plus 3, x to the 4th. So we can write d dx of y as dy dx is equal to differential of sine 4x plus 3x to the minus 4. We're just manipulating the indices to make it a different form. And let's recall from our formula sheet, anytime you see me put up a rectangle looking like this has been extracted from the formula sheet we did earlier. So you could pause the video and go back and look at it. The differential of sine ax is equal to a cos ax. So if we look at the question here, we're trying to find out the differential of sine 4x. So in that case, a is 4. So when we differentiate that, we're going to get 4 cos 4x. Plus when we differentiate 3x to the minus 4, or ax to the n, it gives us an x to the n minus 1. So 3 times minus 4 is minus 12. And x to the power minus 4 minus 1 is minus 5. But let's look at what they're asking us. Differentiate the following expression with respect to x, simplifying your answer. So we can write it as that. And that will be good. Or we can rewrite it. dy dx is equal to 4 cos 4x minus 12 over x to the power 5. Let's now move on to part B. Part 1, determine the coordinates of all the stationary points of the curve y is equal to 1/3 x cubed minus 5 on 2 x squared plus 4x minus a half. If you look at the coefficient of x cubed, we can see it's positive. It's 1 plus 1/3, which means the graph is going from the bottom left side, if you're trying to sketch it, going up, coming down, and going back up again to the top right side. So if we differentiate in this, because we want to find the stationary points, so d dx of y is d dx of that entire cubic expression. And if we differentiate 1/3 x cubed, we're going to get 1/3 times 3x squared. 1/3 times 3 will leave us with x squared. We differentiate 5 on 2, x squared. It'll give us 5 on 2 times 2x, which will give us just 5x alone, keeping the negative sign. We differentiate 4x, we'll just get 4. We differentiate minus a half. If we differentiate a constant, then it disappears because it'll be 0. So we found dy dx, x squared minus 5x plus 4. And we are looking to find the coordinates of the stationary points. At the stationary points, dy dx is 0. So we can say 0 is equal to x squared minus 5x plus 4, which means we have a quadratic equation now equal to 0. And we can either solve for x here using the quadratic formula, or we can take a look and see if it can factorize. So this can factorize, so we're going to get 0 is equal to x minus 4 by x minus 1, which means either the first factor is equal to 0 or the second factor is equal to 0. So if either the first factor, x minus 4, is equal to 0, if that was the case, 0 times anything would give us 0. Therefore, x would be equal to 4 for one stationary point. Or the second factor, x minus 1, is equal to 0, which means x is equal to 1. So we got the two stationary points are located when x is 4 and x is 1. Let's look at the question. What do they want? They want the coordinates of the stationary point. So they've got the x coordinates, but we haven't gotten the y coordinates as yet. So let's now go and take the value of x being 4 and substitute it into the original equation. That way we can solve for y. We have the original equation already, 1/3 x cubed, so forth. And we just put the x as 4 in there. So now if you look at the second line that we just wrote, the only unknown is y. We can solve for that. 4 cubed is 64. 64 over 3. Minus 4 squared is 16. 2 into 16 is 8. 8 5s are 40. So it's minus 40. Plus 4 4s are 16. Minus 40 plus 16 is minus 24. Minus a half. And that simplifies. So y is equal to minus 19 or 6. Right? I prefer that my students write it as fractions, even if it's improper, rather than writing it as trying to convert it to decimals and then having to round off, because this will be minus 3.1666 recurring. So when x is 4, we've solved for y. So we found the coordinates of one stationary point. Let's do it for the next stationary point when x is 1. Repeat the same thing, put it into the formula. Y is equal to 1/3 x cubed, etc. And 1/3 times 1 cubed is 1/3. Minus 5 on 2 times 1 squared is minus 5 on 2, plus 4 minus a half. So y is equal to 4 over 3. So we found the stationary points. They are 4 minus 19 over 6 and 1. Let's go on to part 2, where it says, hence, determine the nature of each of the stationary points in B part 1. Hence means we're going to look at B part 1 and extract information from there in order to work out part 2. If we would like to find out the nature of each of the points, to find the nature of the stationary points, we need to differentiate a second time. So we have to take dy dx and differentiate a second time. That is known as d2y dx squared. which means d dx, differentiate dy dx. Now, if we look at our second line of working on the left-hand side, we know dy dx. So dy dx is x squared minus 5x plus 4. We're going to differentiate that. If we differentiate x squared, we're going to get 2x. We differentiate minus 5x, we're going to get minus 5. And if we differentiate any constant, in this case plus 4, it is 0. Your teachers have already explained that when we differentiate it, we're finding the gradient and so forth, so I won't go into that. Now we know d2y dx squared, 2x minus 5. So let's now find out at each of the stationary points what their nature is. So when x is equal to 4, the first stationary point that we found above, d2y dx squared is 2x minus 5. So that's 2 4s are 8 minus 5. 8 minus 5 is 3. Plus 3 is greater than 0. Anytime d2y dx squared is greater than 0, at the point where dy dx is 0 at a stationary point, then it indicates that we have a minimum point. So that means the curve will be, if we're looking at the curve from the left to the right, it'll be going down, it'll hit a minimum point and then start to climb back up. When x is equal to 1 for the next stationary point, d2y dx squared is 2x minus 5. So we're going to substitute 2 times 1 minus 5. 2 ones are 2. 2 minus 5 is minus 3. Minus 3 is less than 0. Anytime d2y dx squared is less than 0 at a stationary point, it implies that it is a maximum point. So now let's bring up the sketch that we have completed this part of the question and see what it looks like. As we stated, because the coefficient of the cubic part was positive, it would start from the left side, bottom, or left infinity, negative infinity of x and negative infinity of y. It'll come up to a maximum point when x is 1 and y is 4 over 3 or 1.33. And that is a maximum point when x is 1. We just worked that out. And it'll come down until it reaches x is equal to 4 and y is minus 19 over 6. And then it'll start to go back up. So at the point when x is 4, it's a minimum point. So it supports our solution. Let's now go on to part 4C, still in calculus, where this question now says the length of each edge of a cube is increasing at a rate of 0.25 centimeters per second. So we see the cube here, and the cube is expanding. Each side is increasing by 0.25 centimeters every second. Calculate the rate of change of the volume. So as the cube itself expands, it's growing, then let's say it's absorbing water or something else and causing it to grow. As it's expanding, the question is asking us to calculate how fast the volume is changing, the rate of change of volume. And it's going to be, and that will vary, but it will give us an exact value when the length is 8 centimeters. When the length is 8 centimeters, there's an exact value for the rate of change of volume. So what do we know? We know centimeters per second. 0.25 in the first line. Centimeters is a length. Per second is a time. So we know, look as it expands there, and we're interested in point when it goes to 8 centimeters. We know dl dt, the change in length per second, is 0.25 centimeters per second. So hopefully units can see where the rate is explained. dl, change in centimeters or change in length. dt, change in time, which is in seconds. So dl dt is 0.25 for this question. And what do we want to find? Calculate the rate of change of volume. So volume is changing with respect to time, so we consider that to be dv dt, the change in volume per time. So how do we calculate that? We need to have a formula which connects dv dt with dl dt. And this is considered to be a chain rule. If we look at this here, how do we get, we have dt on the left side in the denominator, we have it on the right side already. So that's fine. We have dv on the left side in the numerator, and we need to end up with dl there on the right side. So if we multiply by dv dl, we can see technically the dl in blue cancels off with the dl in green, and we're left with dv in the numerator, dt in the denominator. Now that we know this, what else do we know? Let's recall for a cube, the volume of a cube is side or length times breadth times height. And length, breadth, and height are all the same. So it's length times length times length, which is length cube. So V is equal to L cube. Can we get the indicator of what is blue? dV dl now? That means we have to differentiate volume with respect to length. And if we do that, we're going to get 3L squared. So now we can rewrite this equation. dV dt is equal to dV dl multiplied by dl dt. We know dl dt in the first line, 0.25. We know dV dl is 3L squared. And L can vary. So if we look back at the second line of the question, at the last it says, at the instant when the length is 8. So let's substitute 3L squared where L is 8. So we have 3 times 8 times 8 times 0.25, or quarter. Quarter of 8 is 2. 2 3s are 6. 6 8s are 48 centimeter cube per second. Because it's volume per second. Now, going on to number 5, still the second question in the topic of calculus. Determine the integral of the square root of 2x plus 1. So if we recall from the formula sheet that if we differentiate ax plus b, a linear expression, to the power n, then it becomes an ax plus b, the same linear expression, to the power n minus 1. This is given in the formula sheet. So if we want to find the integral, let's integrate both sides. Then the integral of axb to the power n minus 1, we can move the an across. So it looks like this. ax plus b to the power n minus 1 is ax plus b to the n. And an is a constant. We can carry that across the an in the denominator. I've highlighted a in red and b in purple, and of course n, so we can substitute accordingly. Now, if we look at our original equation there, a is the coefficient of x, which is 2. B is plus 1. And of course, n is a square, n minus 1, sorry, is a square root, which is also known as the power half. As such, n is equal to 1.5, or 3 over 2. So we know a, b, and n, so we can substitute accordingly. So the integral of 2x plus 1 to the power a half is equal to 2x plus 1 to the power n, which is 3 over 2, divided by 2 times n, 2 times 3 over 2. So 2 times 3 over 2 is 3. So we left with 2x plus 1 to the power 3 over 2, all over 3 plus c. C is a constant of integration. Let's move on. That was part 1. In part 2, integrate sine 2x plus 5 cos x with respect to x. So let's recall from the formula sheet, they gave us the differential of sine ex is equal to e cos x, the differential of cos ex is equal to minus e sine ex. So if we want to integrate, let's look at the second set of equations below and integrate both sides. Then we're able to integrate sine ex. So if we write it back, we consider a to be 2. When we integrate sine ax, the minus a will go across, we'll divide on the other side, and the value of a is 2. So that will give us minus a half cos 2x. And on the top line, when we integrate cos ax, it will give us 1 over a sine ax if we divide both sides by a. So integrating 5 cos x will give us 5 sine x plus c, the coefficient concept of integration. Part B now. Figure 1 shows the region enclosed between the x-axis, and there's a diagram that's given to us there. Hopefully you've seen it. The y-axis, the curve, which we have in red, y is equal to x squared plus 2, and the line x equal to 3, which is in blue. Calculate the area of the shaded region, which we've brought up in yellow. So how do we find area? If we are taking the area about the x-axis, then area is equal to the integral of y with respect to x between the limits a and b. A and b are the x values. So on one end x was 0, so on the other end x is 3. So we say integral of from 0 to 3 of x squared plus 2, because that is what y is, divided by dx. Integrate x squared, you're going to get x squared over 3, plus integrate 2, you're going to get 2x, plus c, between the limits of 0 and 3. And if we substitute, we're going to get 3 cubed over 3, plus 2 times 3, plus c, minus 0 cubed over 3, plus 2 times 0, plus c. And what happens? 0 cubed will go to 0. 2 times 0 will also be 0. And we have plus c minus c. So that will cancel off as well. So we're left with 3 cubed over 3. That would be 27 divided by 3 is 9. Plus 6 is 15. 15 minus 0. As such, the area of that shaded region is 15 square units. So that was 5a and b. Let's go on to C now. Figure 2 shows the shaded region enclosed between the x-axis, which we have in black, the y-axis, which we have in purple, and the curve 4 minus x squared, which we've shown that shaded region in yellow. And of course, the curve is in red. So we have the enclosed area. If the region is rotated about the x-axis, let's rotate it through one complete revolution. Calculate the volume of the solid formed. So how do we do that? Volume of a shape which is rotated about the x-axis follows the formula pi integral of y squared dx from the limits, just as we did before in area, the x value starting at a and x value ending at b, from 0 to 2. So pi, the integral from 0 to 2 of y squared. Now y is 4 minus x squared, and we're going to square that. 4 minus x squared, all squared, with respect to x. And there are a couple of different ways to do it. One way, we can just work out the brackets by saying 4 minus x squared times 4 minus x squared. So it'll be 16 minus 8x squared plus x to the 4th with respect to x. And if we integrate 16, we're going to get 16x. We integrate minus 8x squared, we're going to get minus 8x squared, x cubed on 3, plus x fourth will give us x fifth on 5. Plus c, constant of integration, between the limits of 0 and 2. Those are your limits for x. So if we substitute, y is equal to 16 by 2 minus 8 by 2 cubed on 3, plus 2 to the 5th on 5, plus c, minus 16 times 0, plus 8 times 0, plus 0 to the 5th, all those going to disappear. So anything multiplied by 0 will disappear. And we have plus c in the first brackets, minus c in the second brackets. That will also go. So we're left with 16 by 2 is 32, plus 2 cubed is 8, 8 is 64 on 3, plus 32 on 5, which works out to be 896 pi on 15 cubic units. And that will be the volume of the solid form with this rotation. Let's now move on to number 6, which means that we have completed calculus and we're moving to the last section of the paper, which is probability and statistics. So in part A, if PA, the probability of choosing an event A is 0.8, and PB, the probability of choosing an event B is 0.5, and the probability of choosing either A or B, A union B is 0.9, calculate that conditional probability. So let's just bring up a sketch so we know exactly what it looks like. So A, its probability is 0.8, and the probability of B is 0.5. And what else do we have? We have A union B. So that means this blue area, which is A alone, the purple area, which is both A and B, and brown area, which is B alone. Those three areas make up the union, A union B, which is 0.9. As such, everything outside that, the complement, is 0.1. We just want to put a visual, right? Just as your teachers do in class, in order for you to get a grasp of it. Conceptual understanding is being able to see in your mind some sort of picture or model or illustration of the situation, not just writing abstractly. So let's bring up the formula given in the formula sheet. Probability of A union B is probability of A plus probability of B minus probability of A intersect B. And we know three of those. 0.9 is equal to 0.8 plus 0.5 minus the intersection probability. So 0.8 plus 0.9 is 1.3. We carry it across, 0.9 minus 1.3 is minus 0.4 is equal to minus the probability of A intersect B. So if you multiply by minus 1 on both sides, then the probability of A intersect B is equal to 0.4. Is that what was required above? If we go back and look at the question above, you would see they wanted us to calculate the conditional probability. So why are we calculating the probability of the intersection, which is in purple? So what this tells us is the purple area is 0.4, the blue area is 0.4 because 0.4 plus 0.4 is 0.8. The brown area is 0.1. So 0.1 plus 0.4 plus 0.8 is 0.9. So the conditional probability is the probability of the intersection, the purple area, over the probability of the entire A, which is blue and the purple. So it's 0.4 over 0.8, which works out to be a half. So the conditional probability is 0.5. Let's move on. We've just completed part A. Let's go into part B. A fair blue dice has each of the numbers 1, 3, 5, 7, 9, and 11 on its faces. So it means it has 6 numbers, and it's not the traditional numbers that we're accustomed to. A second fair red dice has the numbers 2, 4, 6, 8, 10, and 12 on its faces. So we have a red die and a blue dice. The dice are rolled simultaneously, and the sum of the numbers on their faces are recorded. So when you roll the two dice together, whatever it rolls, you will add the red dice face number and the blue dice. Part 1, complete the possibility space table below by inserting the sum of the two dice on each roll. So if we look at the table, we have a red dice. What are the possibilities? 2, 4, 6, 8, 10, 12. 6 possibilities. And blue dice, the possibilities are 1, 3, 5, 7, 9, 11. As such, 6 by 6, we're going to have 6 squared, which are 36 possibilities. The first sum and the last sum have been inserted for you. So if we call blue dice before the red dice, just for simplicity, then 1 from the blue dice plus 2 from the red dice, 1 and 2 is 3. That's the smallest possible number we can roll. And the largest possible number we can roll is the largest number from blue, which is 11, plus the largest number from red, which is 12. So 11 and 12 is 23. So part 1 is asking us to complete this table. So let's, that should be simple enough. We had 1 and 2 is 3. Let's add again 1 and 4. That will give us 5. 1 and 6 will give us 7. 1 and 8 will give us 9. 1 and 10 will give us 11. And 1 and 12 will give us 13. And let's look at the next row. 3 plus 2 is 5. 3 plus 4, 7. 3 plus 6 is 9. 3 plus 8 is 11. And 13 and 15. If you notice, we're adding odd numbers from the blue die plus even numbers from the red die. When you add an odd number, which is generally 2n plus 1, and we add an even number, which is 2n, then we're always going to get 2 to the n plus k plus 1. There will always be an extra term if we're paying off, which means that all our answers when we add an odd and an even will always be an odd number. And that's what we're seeing in these first two rows. Let's continue. 5 and 2 is 7. Let's go a little quicker. 5 and 4, 9. 5 and 6, 11. 5 and 8, 13. 5 and 10, 15. 5 and 12, 17. You can see the answers increasing by 2 as we go across the rows. 7 to 9, and if we keep adding 2, 11, 13, 15, 17, 19. And remember, maths is patterns. So we see any patterns here. 9 and 2 is 11, and 13, 9 and 6 is 15, 17, 19, 21. 9 and 12 is 21. 11 and 2 is 13, 11 and 4, 15, 17, 19, 21. And we have 23 already. So we have completed the possibility space table. Let's now look at part 2. State the probability that the sum of the scores from throwing the dice in B part 1, which we just wrote down, is prime. So let's look at those 36 possibilities, starting with 3 as the smallest and 23 as the largest. Then, which are the prime numbers? 3, 5, 7, 11, 13, 5, 7, 11, 13. Next row, 7, 11, 13, not 15, 17. So the next row, we have 11, 13, 17, 19. We have 11, 13, 17, 19. And the last row, 13, 17, 19, and 21. Sorry, 23. So if we count them up, in the first row we have 1, 2, 3, 4, 5. Next row, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have 25 prime numbers out of 36. Remember when we talk about probability, it is how many qualify, which are how many prime out of the possibilities, which are 36. That is first one, right? So we stated the probability that the sum of the scores that were thrown were prime, well, the probability is 25 out of 36. What is the probability that the sum thrown was even number? Well, none. 0 out of 36, or just 0. Good, let's go on now to 6 part C. So in this question, they're asking us, because this really brings us to the, still in the area of probability and statistics, calculate the interquartile range of the data set represented in the stem and leaf diagram below. So the stem shows 3 to 9, 3, 4, 5, 6, 7, 8, 9, and we have the leaf on the right of it. And the key tells us that if we have 3/0, it means 30. So we have 30, 31, 33, 33, straight up until the largest numbers are 85 and 92. So here, we can split this up. And why were we able to do that? Because we had 4 and 3, 7 and 6, 13, 14, 15, 16, 17, 18, 19, 20 numbers. And the middle of 20 numbers would be somewhere between the 10th and 11th numbers. So 4 and 3, 7 and 3, 10. We have 10 numbers before that purple demarcation and 10 numbers after it. So that means our median would lie between 56 and 58. So let's see what the question asks. The question is asking us to calculate the interquartile range of the data set. In order to do that, we don't really need the median, which is Q2, but we need the lower quartile, which is Q1. So let's look at the first half of the numbers, which are 30, 31, 33, straight up to 51, 56, 56. The first 10 numbers. So it's the middle of 10 numbers. If we put up 10 fingers, the middle of them is between the 5th and 6th. So that means if we looked at the 5th number, it's 42, and the 6th number is 44. So what's the middle of 42 and 44? Well, we could easily identify it on number line, or we can just add it and divide by 2, and it's going to give us 43. So that's Q1, the lower quartile. Let's look at the upper quartile now, Q3. Q3 would be between the 15th number and 16th number. The second half starts from 58. That's the 11th number, 59, 59, 12 and 13, 64, 14, 67 is 15, 67 is 16. So what number lies between 67 and 67? Of course, it's itself 67. So Q3 is 67, Q1 is 43. Let's look at the top. They're asking us to find the interquartile range. So the interquartile range is Q3 minus Q1, which is 67 minus 43, which works out to be 24. So that is the IQR, the interquartile range. Let's now move on. That was part C. To part D. The figure shows a box and whisker plot, which represent a set of numerical data. We can see the box is from 20 to 53, and the whiskers are on the left and right of it, which are from 20 to 10, and from 53 to 74, those are the whiskers. So we have the box and whisker plot. And Q1, Q2, and Q3 will be based on what's happening at the box. From the extreme left, the smallest is Q1. Q2 is the demarcation there, but showing us the median. And Q3 is the upper quartile. Part 1, say the median of the data set. Well, that we already said that as Q2, which is 27. Determine the range of the data set. To find the range, we need the largest number, which is indicated on the right as 74, minus the smallest, which is 10. 74 minus 10 is 64. And part 3, describe the shape of the distribution. Well, look at Q2. Q2 is not really in the middle of Q1 and Q3. It's more to the left, very close to Q1. It's only 7 away from Q1. It's 26 away from Q3. As such, we can say the median Q2 lies closer to Q1 than to Q3, which means the data set is positively skewed. Let's go on to the last part of the last question in this paper, which is 6E. And it says, 5 out of 30 students in a class were randomly selected. But this means we are not talking about an entire population, but a sample. And the heights recorded in centimeters are shown. So student A, whose height is 135 centimeters. Student B, 144. Student C, a little shorter, 137. Student D, 146. And tallest student is student E, 153. This is a sample that's pulling 5 students randomly out of 30. Calculate the variance of their heights in square centimeters. So let's recall, if we have these values here, we can find the mean x bar. X bar is the sum sigma of the terms from the first term to the nth term. In this case, from the first term to the fifth term. So we have to add up those 5 terms and divide by n, which in this case is 5. So it's 135 plus 144 plus 137 plus 146 plus 153 all over 5, which works out to be 143. So we know the mean. Why did we want to calculate that? Because that formula that we quoted in the box was given on the list of formula under probability and statistics. And also this formula for variance, S squared. S squared is the sum of the terms from the first term to the nth term. So let's say the first term to the fifth term of the difference between the term and x bar, the mean, squared, all over n minus 1. So if we worked out x bar 143, can we get the difference for student A between his height and the mean height? Well, 135 minus 143, and that works out to be minus 8. For student B, 144 is his height, minus the average, which is 143. 144 minus 143 is plus 1. For student C, 137 minus 143 is minus 6. And student D is 146 minus 143 is plus 3. And finally, 153 minus 143 is 10. So we got the terms in the brackets, xi minus x bar. The individual heights minus the average height. And now it's asking us to square it. So let's square it. And we're going to get minus 8 squared is 64. Plus 1 squared is 1. Minus 6 squared is plus 36. Plus 3 squared is 9. Plus 10 squared is 100. All the values will be positive. So if we look at the formula, the variance, which is s squared, is equal to the summation of I equal 1 to 5. Because n is equal to 5. So how do we add those 5 terms? Well, what terms are we adding? We are actually adding the difference, x minus x bar squared. Those 5 terms, which we have in the extremely right column, all over n minus 1. So 64 plus 1 plus 36 plus 9 plus 100, all over not n, but n minus 1. N would be if we're doing the entire population, but we're using a sample. So the sample is n minus 1, which is indicated in our formula. So 64 plus 36 is 100. 100 plus 100 is 200. 200 plus 9 is 209. Plus 1 more, 210. So s squared is 210 divided by 4. 4 into 210 is 52.5. We have now come to the end of CSEC past paper questions in additional mathematics, specifically paper 2s. We started doing entire papers from May 2023. Now we have all the solutions when additional mathematics started in May 2012, but all the solutions from 2012 to 2022 are not done by entire papers, but done by topics. So you can go and look at the old videos or the playlist for section 1 and get 2 videos showing 5 years and the other 5 years, 10-year solutions only on section 1. And then another playlist for section 2, section 3, section 4, the 4 sections. Since that we already have enough for students to go through and follow, so they can build a good understanding of how assessment is taking place in the subject. From 2023 onwards, up to this year, 2025, we are doing complete past paper solutions. Of course, we did 2024 as well. So don't forget to look at the description down below where we identified all those places and the order the videos should be looked at for you to get a good understanding. So thank you very much.